my name is Sarah and I'm a scientist at Procter Gamble. Procter Gamble make a wide range of household products such as nappies, makeup and laundry products.
Hi, I'm Shona and I'm also a scientist working at Procter Gamble in the research and development area of the company. Both Sarah and I work in the hair colourant department. Before understanding the chemistry of how a hair colourant works, firstly we must understand the structure of hair. Hair is mainly made up of a protein called keratin. The protein is a long chain of amino acids, mainly cysteine. Each hair fibre has three main areas: the cuticle, the cortex and the medulla. The cuticle is the outside of the hair and is responsible for the feel of the hair. It has a structure like overlapping tiles on a roof. Inside the hair is the cortex, which contains strands of keratin fibres twisted together. This gives the hair both strength and structure. The cortex also houses the melanin, which is a coloured molecule that gives the hair its natural colour. In the centre of the cortex is the medulla, which is a hollow airspace running down the centre of the fibre. We have instruments that allow us to visualise the fine structure of hair, such as a scanning electron microscope, which is a highly magnifying microscope, which we use to magnify the hair up to 3,000 times.
A hair colourant contains two key components: the tint, which contains the ammonia and the small dye molecules, and the colour developer, which contains the hydrogen peroxide. When the tint and the developer are mixed together, the ammonia and the peroxide cause the hair to swell and allow the small molecules, dye molecules, to penetrate into the hair. Inside the hair, the peroxide bleaches the hair's natural colour and initiates an oxidation reaction between the dye molecules. The small uncoloured molecules join together to make larger colour molecules which give the hair its final colour. The small uncoloured molecules are based on benzene rings with 3 double bonds. When the developer is introduced, the peroxide causes an oxidation reaction, allowing the benzene rings to join together to form a large molecule with many double bonds. When electron-rich groups such as amino or hydroxyl groups are present alongside a series of double bonds, this causes the molecules to become coloured. After colouring, when the hair is rinsed with water, it causes the hair to de-swell and the cuticles to close, allowing the dye molecules to be trapped inside, causing the final colour.
To check if the final shade created is correct, we run several lab tests. Firstly, we check the pH of the tint. This should be highly alkali, usually around pH 10. We then mix the tint and developer together and apply this to tresses of human hair to check the final colour. These are then analysed by both expert visual assessors and also by a spectrophotometer which measures the colour. When we have a shade which passes all of our testing, we give this shade to our stylists in our test salons around the world. Stylists then use this product on clients to make sure it meets all of the consumer expectations. For example, it must cover all the grey hairs. Throughout school and university, I learned a lot of science theory, but I found it hard to relate to real life. In my job today, on a daily basis, I use that theory to create products that people use at home every day.